This presentation gives you a quick overview to the new ground vibration mode of the 958 and 958A. Just to go through the settings briefly and then store some data. We'll then download that data into SVAN958A. That'll be a subject of the next video. So if we start with the 958, here's the screen, the front panel. And this is how the instrument normally wakes up, with just a twin display of measurement results. So to go into the settings menu, shift and menu to get into the main menu of the instrument, and then if we go to the function menu, this allows us to select the mode of operation of the instrument. Now at the moment I'm set to ground vibration, which is this new mode. In fact, you can perfectly happily do ground vibration measurements in the normal level meter mode, as this allows you to set things like weightings, WD and WB on the acceleration channels, or you can measure peak particle velocity in the same way. But one of the downsides potentially of the level meter mode is that you can either measure VDV or PPV, but not both at the same time. So we introduced this new mode not so long ago, called the ground vibration mode, which one of the key features of it is that it allows you to measure PPV and VDV in the same channel at the same time. Additionally, this mode allows the operation of FFT as well, and also audio recording. So, for example, you can calculate dominant frequency as required by BS7385, and you can also capture waveforms if you want to analyze the vibration transients in more detail. Now, both of those are options, the FFT mode and the signal recording options, but they are activated through the ground vibration mode. So let's select that mode of operation. While in the main menu, you obviously need to set up your calibration. I'm going to be using an SV84 triaxial accelerometer, and this has a sensitivity of nominal 100 millivolt per meter per second squared. But you would put in the values here for the transducer that you're using. But just bear in mind that with an SV84, the calibration factor should be roughly minus 20 dB. It will obviously vary according to the individual sensitivity of the accelerometer. So now, with both the function selected and the calibration set up, we can now go into the input menu of the analyzer and set up our measurement. So the first part is the timing of the measurement, if you like. And here you can put in the integration period for your background vibration measurements. Now, BS7385 says we need to log measurements of vibration continuously to ensure that they don't exceed particular levels. Typically, for continuous vibration, your limits will be around 10 millimeters per second PPV, but your mileage might vary. So here we've got the instrument set up to do a series of 1-minute measurements with an infinite cycle number, and this basically means that it will measure for 1 minute, store a summary result file, and then reset and start again. However, additionally to the periodic measurements, we can also define a logger, and in this particular application we'll use the logger for capturing transients, so that we can then compare them to the reference curves in BS7385. Typically a logger step of 1 second is fine for vibration, and because this particular instrument has the FFT option enabled, I can choose to have FFT enabled, and then I can use that to calculate dominant frequency. So press enter to accept all those parameters. The next is to set up the channels. And if I go into the channel setup here, you'll see that now, in contrast to the normal level meter mode, we have two profiles, P1 and P2. P1 we normally use to measure VDVs and acceleration, so if I go into that and select the appropriate channels, you can see that just like in level meter mode, we can select either the high or the low measurement range. So here, for example, I've set the lower range. Note that this will set the range in all three channels simultaneously. Being channel 1, which is typically the X direction, we would select WD as our weighting filter, but clearly if we go into channel 3, we'll see that again, typically the Z direction, we would choose a WB weighting in there. So that's all set up for just profile 1. If we now go to profile 2, which is the ground vibration, here we can choose the frequency range of our measurement. This is the frequency range that we'll use for the FFT analysis as well. And being a velocity measurement, it would be very surprising to do a measurement above 300 odd hertz, so that's quite adequate. And also we can select an appropriate filter, and in this case I've chosen velocity with a 3 hertz bandwidth. Again, typically we don't need to measure below 3 hertz, so a 3 hertz high pass filter is more than adequate. So press enter to accept that, and that will now apply to all three channels. Of course, for PPV there is no weighting, so we don't have to select any weighting values in different channels. Press escape to get back to the input menu, and now we'll go to the logger setup. As I said before, the logger we're going to use to capture transients, and in each transient, let's say in channel 1, we would probably want to capture the VDV value, so the dose value for the transient in profile 1, and the peak value in profile 2, and the peak value with the velocity filter is of course PPV. So each time I trigger a logger, I'm going to capture the PPV and the VDV. Press enter to accept those parameters. Channel 4, of course, is still available to be used as a noise channel, so you could also capture the transient noise in 3 profiles, which of course is available with the sound channels. I won't dwell too much on that because we're concentrating on vibration. So now let's escape back out to the input menu. If you have the wave enabled, or indeed the option on board the analyzer, then you can set that up, but I'll pass that over at the moment. And now, because we've got FFT available in the measurement setup, I've got some parameters that I can set here. Now, normally the mode that you would select for the transients is something called peak frequency. The frequency band is selected automatically by the profile 2 settings, and then in the logger we're going to log the dominant frequency value. So basically we're taking a waveform, we're calculating the FFT, and from that FFT we're calculating the peak frequency. We can then use that information, as we'll see in the software, to compare to the BS7385 limit curves. So we're all happy with those settings, that's good. The last thing we need to do is to set up the triggering for the transient capture. So what we're going to do is to use a logger trigger, but the first thing we need to do is to go down to the bottom of this menu and define the trigger event setup. So press enter, and you can trigger off any channel. So if I select channel 1, for example, and you can either trigger off profile 1, which if you remember is VDV, or profile 2, which is PPV. And within each profile you can have 2 triggers. So one could be used for amber and one could be used for red, for example, for monitoring applications. So if I go into event 1, you can switch on the trigger here and then set the parameters. For example, here's one which is set to the level of the source, and the source in this case is the PPV, so peak, and the integration time is the logger step. So in other words, if the 1 second PPV value goes above 10 millimeters per second, then we can do something. And what can we do is defined in the trigger actions, and here for example you can send alarms if you want to, or if you have the remote control possibilities available, you can send SMS, send email, but we're going to trigger a logger, so we'll enable that. So once that's set, we can accept those settings by pressing enter and escape to get back to the trigger menu. So now we need to go up to the logger trigger line, because we're going to use the triggers that we've defined to start the logger. So press enter to that. Let's enable the logger trigger, and now we can select the sources from what we put in the last menu. So now we can say select sources, and in fact I've got two sources enabled here, both channel 1 profile 2, which is on peak, and channel 3 profile 2. You can have both of those if you want, or if you just want to trigger off the vertical channels, you can disable one of them here, for example. So this is now set to trigger loggers on just channel 3, which is typically the vertical channel, at 10 millimeters per second ppv. Press enter to accept those, and the logger is now set up to trigger using my defined settings. The last thing to do, and this is quite important because it's a commonly made mistake, is to just check that the file save in the instrument is set up to autosave. Otherwise you won't get any data. You'll still get your logger data triggered on level exceedance, but you won't get your background data unless you save the result every 1 minute in this case. So come out to the main menu, go down to the file and save options. Come down here and make sure that this is set to autosave number, and then you can choose to put in a root name for your file. Currently I've got it set to RES373. I would recommend that you make the root of this file as short as possible, something like a single letter for example, and that will then allow you to have virtually unlimited number of files stored. So to change it, you simply just use the cursors here to go to the various part and then put in the file name that you want. Press enter to accept all those values. The last thing to do is just make sure that you've got enough memory. I would suggest saying delete all and starting with the clear memory, but you might already have some precious data in there that you haven't downloaded yet. So just go down to the free space menu and check that you've got a reasonable amount of space left. In this case I've got over 90% in both the regular memory and also the logger memory, so I'm not going to run into any problems there. So that's it. All we have to do now is to actually start the measurement and see what we've got, and this will now do a series of measurements every minute, store the result, and if the level in the vertical channel in this case goes above 10 millimeters per second, it will store a logger and also capture the FFT, which will give me the dominant frequency. We can then download those results to software, and we'll cover that in the next tutorial.